Thank you so much for coming to our talk today. We're really excited to present to you Pluto, how the Department of City Planning builds data. Pluto is a flagship data product that the Department of City Planning puts out. We will use that data product to show to you all how we build data products. So we'll use it as an example. Okay, so this is our agenda for today. We will introduce ourselves. We will talk a little bit what DCP does, Department of City Planning, what we do as data engineers within DCP. Then we will cover what Pluto is, how we build it. Next, we will go into tech stack we use. And last is our plans. And then we will leave some time for Q&A in the end. All right, so this is us. Fun fact, so when I joined the team, I was like, I'm a cat person. Everyone around me knows that I have a cat. I think I'm paying for Google Cloud just to store my cat pictures. And so when I joined, I'm like, okay, I should not talk about my cat. Like, I don't want to give perception that I have this cat who is my entire world. I want passion. And then I happened to show a picture of my cat. I'm like, damn it. And then I realized that my entire team has cats. And then we just started sharing pictures around. And I was like, oh, maybe data engineers have a trait to be cat people. So that's just a fun fact. And we're like, we need to show off our cats. So yeah, my name is Sasha Filipova. This is my cat Julian, and I am the data engineer on the team.
My name is Finn Van Krieken. I've been with City Planning for just barely over a year, and that is my cat, Tuna.
Hi, Damon McCullough, senior data engineer. I joined a little over a year ago, and that is Naboo in the front, Davika in the back, and the dog is not in the picture because we made this cat focused, but I just wanted to make sure everybody knew. There are dogs. And Alex joined us, I want to say about 8-10 months ago, maybe, and he is enjoying Scotland at the moment, unfortunately.
Yeah.
He's not here with us.
Just an interesting note, we're highlighting all of us have started roughly in the last year, since the beginning of 2023. So it's a very new team, a sort of a new cohort here at Data Engineering.
Yeah. All right, so let's dive into it. What is the Department of City Planning? What we do as the agency? So I'll call it as DCP, just easier to pronounce. DCP is the primary land use agency in New York. And city planning partners with other agencies on projects that involve rezoning and environmental reviews. And one of our strategic objectives as the agency is supply data to a broad range of planning functions and stakeholders. It's also worth mentioning that DCP has a long history of producing critical citywide geographic data sets. So not just zoning, land use related, but there is a wide range of data sets that we produce. Okay, now we want to briefly spend some time what data engineers do in general, just to combine it together, what data engineers do inside of DCP. So let's talk about data engineers. The main difference between us and data analysts is that our final outcome, our final product is a data set, so we produce data. And data analysts, they take this data or consume it, and then their final product is a report, is a set of predictions, insights. And so this is why we also call it data product. It's like a fancy way to call it it's a data set, but that's our product. So yeah, we build data pipelines, another fancy word. I'll explain how I understood it when I was transitioning into data engineering. Let's say you have a data set. You extract it from somewhere, maybe from open data. Then you need to clean it. You may need to merge it with other data sets, and then it's ready for analysis. So that process, when you automate it, it's a data pipeline. And so when we say we build data pipelines, we build multiple processes for these data sets. And because we'll talk about data pipelines, and it's really a process of us getting data maybe from inside of the agency or from outside of the world, and then we do some wrangling, some cleaning, some merging, and then we give it to our consumers. Next slide. All right, so now we're ready to talk about our mission as the data engineering team. We talked about what DCP does, about one of its strategic objectives. We talked what data engineers do. Now let's combine it all together and talk about our mission, which consists of 4 pillars. First one, like I said, we develop data products. And it's worth noting that some of our products, they are mandated by law, so we simply have to put them out with certain frequency. Thank you. And some data sets we develop is for Department of City Planning, various initiatives. Next one is operation. The way I like to think about it is how we produce data. So there are a few points to this. First one, we are a public agency, so we want to make our processes as transparent as possible. Second one, again, we want to automate our data pipelines as much as possible. And third one, we want to be cautious with our financial resources, so we want to make sure we use our resources responsibly. Third one is ecosystem, which is over more than just data, but also comprehensive documentation and metadata. Well, for this one, if we just put out data to the world without explaining what it is, how it can be used, it doesn't really have much value. So we want to make sure we tell you what it is. We provide metadata and any other documentation telling you what this data is and how it can be used. And the last one, community. We partner with internal teams and with other agencies. We come to events like this because we want to share our work. We want to show what we do in case somebody finds it useful, and we also we want to learn from others. All right, so now that we talked about mission in general, so what we do, I want to touch on some guiding principles that come to the time when we code, like when we develop our products, things that we keep in mind. So first one is automation. When I was talking about that example of getting data from somewhere, cleaning it, preparing for analysis, we want to automate it. We don't want to spend a lot of time on this. We want ideally to click on a button and it will just do it for us. Second subpoint is modular code. So when we develop products, we want to make sure we do it in a way that when we create a new data product, let's say we get a request for a new data set, we want to make sure that we have a framework that we can take and start using it and not to spend too much time developing a new thing. And also we want to be able to develop more products. I'm talking about scalability. Or let's say we want to put our data sets more often. Again, we want to have the capacity of developing more products and more often. Maintainability. The way I understand this is when we develop our products, we want to make sure we think ahead, that whoever comes after us, they can read our code and they know what's happening. And it's also easier to onboard new team members. And again, when something breaks, we know where to look for. We don't want to spend too much time debugging. And last one, high data quality. So for this one, we want to make sure we have sufficient tests in the data to make sure quality is okay. Well, okay, I shouldn't say okay, it's good. I mean, it passes. And we also conduct manual quality assurance review. And I should probably clarify some of it data engineers do, but most of it is taken by domain experts. Okay, so now that we covered what data engineering does within DCP, what it looks like, I would like it to turn to Damon to talk about what Pluto is and how we build it.
Clap. Thank you, Sasha. And I would love to stand, but the slides seem to have a mind of their own, so I'm gonna stay close to the keyboard so that we can control them, just like that. So let's talk about Pluto. So Pluto stands for the Primary Land Use Tax Lot Output. I'm not sure if it's technically a backronym, if they started with the name and worked backwards, but it works. People remember the name Pluto. And what it is that for every tax lot in New York City, we provide lot details, building details, and geographic, political, administrative boundary details. And so tax lot is a term that I didn't really think about until I joined this team. And to me, it also means that for every parcel of land in New York City, we have all these details. And to differentiate real quick, it's all land, but there are tax lots, then there are the streets, there are parks, which are technically on tax lots. So just wanted to differentiate real quick between streets and tax lots, because that's a big, I think, distinction when it comes to land use in New York City. More specifically, so for every tax lot, we're talking about a unique identifier that is the borough it's in, the block that it's on, and the lot that it's on. So I'm going to start using an acronym soon, BBL, which stands for Borough, Block, and Lot, which identifies each and every tax lot in New York City as distinct. This is what it looks like on open data. This is probably how most people see it. I think they've done a major upgrade to being able to preview data and query it with SQL-like things in the interface. So you can see things like this, and below this, which I didn't include in the screenshot, are a lot of abilities to filter and investigate data. So right now, all we just see are a few of the columns, but there are some hints at what's to come in the bottom right already. That's a lot of rows. So that's every tax lot in New York City. So this data product, as we often call them, or data set, started in 2002. At first, it was released yearly. I wasn't sure whether to say yearly or annually, but I like yearly. Quarterly since 2021, and now about monthly. We're doing our best. This is a brand new sort of release schedule, and we're trying to release this every month now for reasons that we'll get into. How is Pluto used? I probably don't have to tell a lot of people in this room how it's used. I suspect there are a lot of Pluto. Actually, how many people in here have used Pluto or do use it? That is a lot. Excellent. So to me, Pluto is used to answer a lot of questions like these. How is New York City's land being used? How was it being used since it's been released since 2002? What can we build on that lot, since what DCP does is often related to zoning, and that is ultimately sometimes the answer to that question, what can I build on this lot? How old is my apartment building is probably the first time I used Pluto for personal use. And who owns that building across the street? I phrased it that way because I think most of us don't know the borough, block, and lot number of a building that we're concerned about. We know exactly where it is. We could zoom in on Google Maps and find it. And so that's what I really like about Pluto and the web portals that present it. You know where it is, but you don't know the tax lot details of it, but you can find it and get these details. So a couple more things about the uses of Pluto. Two of my favorites. One is on the right, and that is part of the Data Through Design exhibition. And I'm going to get the full name of it wrong, but it's really presented as an ATM of Pluto. And because you can access all released versions of Pluto, this art installation presents all of those versions of Pluto, and you can explore land use through time in a really nice physical way. And my personal favorite on the left is just seeing how many times Pluto has been used just by checking Google Scholar. There are other ways to check that in research. And some people may be more familiar with the name Map Pluto, and I'll get into the distinction in a bit. But searching Pluto or Map Pluto in Google Scholar, not just Pluto on its own, you'll get some astrophysics research, I'm sure. But that's 17,000 results, which sometimes there's duplication in Google Scholar, but that's still really interesting to see. And so where to find it? Of course, there's NYC Open Data Portal, but there's also DCP's managed open data portal that we call Bytes of the Big Apple. I love the name. And it is where you can find every version of Pluto. So open data is great for all of the data that it presents, but unfortunately you can only see the latest snapshot or the latest uploaded version of something. We have a link in our description of Pluto on open data that can take you to Bytes, where you can get every version and do things like the ATM project that presents every version. So all versions of Pluto, and I'm not sure if it's the mouse or the keyboard that hates me, but we can see all versions of Pluto are presented on our site there. And we also provide as much metadata and details as we can on the site, because there are limitations to standardize on open data that creates limitations for what we can upload and how much detail we can provide. So what's in Pluto? I think you have a good idea already, but I wanted to start with where we are. So, like I said, we don't know the borough block and lot number of this building, but we all probably looked up the address before we got here. So we know we're at 2 Court Square, Long Island City. We also can now know that we're on a tax lot. This lot has a primary building. Some lots have multiple buildings. And the owner of the building filed taxes, thankfully. So that little shape in the middle, that's the tax lot that we're on right now. And I'll explain where this information is coming from in a bit. So what is here? This lot has this particular shape. This lot has a land use, and the primary building has addresses, unfortunately plural. So this is our lot, a little zoomed in, that's where we are right now. And this is where this information is coming from. So this is Zola, our zoning and land use map. This is how I usually am interacting with Pluto, other than building it. And on Zola, you can find virtually all information that is in Pluto, along with other layers like the actual shapes of the zoning map that overlap with this lot. And so a lot of this is redundant in a good way, because you can see some of the source data that went into Pluto. So if you just click on this tax lot, you can see details about it, but you can also see the other factors that went into those details. And one of my favorite things about Zola is that on the bottom right, you see links to BISWeb and ACRIS. I don't know what they stand for, but I know they take me to more details about this lot that aren't necessarily part of Pluto. So you can find complaints about your apartment building. You can find DOB records. And this Zola kind of serves to me as a directory that takes you to many, many sources about a particular building or tax lot. And you can already see multiple addresses associated with this one tax lot. In the top left, I used the familiar address, but in the top right, another address appears because many buildings have more than one. So Pluto tells us about this lot. It is an irregular pentagon, something I love saying out loud. This lot has a particular land use, commercial and office buildings, and again, it has multiple addresses. And that's what Pluto looks like to us, usually. This building is one row in an entire table, and of course this looks cryptic, but this is the information that ends up in a portal like this or in a table that you're downloading from open data. And so this is a slightly different version of what I showed before, but all of the colors you're seeing now are the actual land uses. And so these are categories that DCP has created that are mapped from tax records. And I'll explain a little bit more of that in a second. But it is nice to be able to, and this is zoomed in, you can zoom out and very quickly see and also analyze land use across an entire area and compare one borough to another using a data set like this. So this is the micro level, but you can always aggregate these things or visualize these things to give a more macro level picture of land use. So again, Pluto is every lot in New York City, 101 columns, 858,000 rows, and growing, perhaps. Pluto is a CSV. Map Pluto is a shapefile or a file geodatabase. So Map Pluto is more geospatial software friendly than Pluto. But in some cases, if you download Pluto, you do still technically have a geometry column. It's just starting out as text and maybe a little harder to process. So we can use those terms interchangeably. Most people want the geospatial information, and often when you're downloading Pluto, you still get it. But we do consider them as distinct things, especially because of the file format difference. And just to shout out that shapefiles and file geodatabases are geospatial data formats that are easier to use, let's say, than CSVs if you're really only in it for the geospatial use of it. So 35 source data sets. They are not all listed here, and I will definitely not walk through all of them, but I did want to highlight the most significant ones. So the Department of Finance is the provider of what we might call the spine of this data set. Every single row in this data set is a tax lot, and we're primarily getting that information from the Department of Finance. Their property tax system, their computer-assisted mass appraisal system, ended up with a good acronym there, CAMA, and the digital tax map is what actually gives us the shape of these lots. Without the shape, we're just talking about tabular data, records, you could call them administrative records, but the shape and location seem to be one of the highest value adds of Pluto, not just having this tabular data and you might know the address and you might know where it is, but being able to put it on a map and see it is always very satisfying. And then Department of City Planning. So I mentioned how significant the sort of geographic boundaries are. If you have a building picked out and you just want to know what school district it's in, you could go and look at a map and see that it sits within a certain school district, but because of the spatial joins that we perform, you now have that in a tabular form to say, looking at this building, what school district is it in? What sanitation, watershed, I think they're called garbage sheds, perhaps, or sanitation sheds. So a lot of those geographic boundaries are boundaries that we're publishing. And so that's source data to Pluto. And another thing to shout out is GeoSupport. So geocoding is difficult, especially in New York City when streets are changing and being created all the time and hopefully sometimes being converted to plazas. But one of our oldest geospatial products is GeoSupport, which is a New York specific geocoding software that is available. We do manage the Python package of GeoSupport and want to prioritize making that more available and useful for people. But we use it all the time to go from address to location, but also for these buildings, there's a lot of information that's already packed into GeoSupport about those buildings. So we don't only have to rely on tax data, we can use our own older but also much more frequently updated systems to get information about these tax lots and buildings. So again, what Pluto's told us about where we are is the shape of it, that's coming from the digital tax map. The land use is coming from, first, Department of Finance, but because it's such a long list of categories, we do provide the mappings in our README, in our documentation of how we go from a long list of categories to a smaller list of land use categories. And that land use is, I believe, primarily coming from the building, what the building is doing. So I just want to differentiate between zoning, which tells you what can be built, and land use, which tells you what's actually happening on that land because of the buildings that are there and the activities that are happening based on tax records. And again, those primary addresses for that building are coming from Department of Finance as well. Nobody wants to see that, but it's real. Finn made this manually. This is mapping from source data to columns in Pluto. And the reason that this is difficult is how many sources we have, how many columns we end up with, and that this has to be done manually. But was a worthy endeavor just to scare people. The truth of Pluto logic is that we put source data in a database, and I'm not going to spoil the details of the technology that we use to do this, but we put source data in a database, we run 59 SQL scripts in order, and then we export those final tables as files. Thankfully, we don't have to click a button 59 times to do that, but this is ultimately how it's done. Now, what's unique about Pluto, to me and to us, is that it's geospatial tax data to indicate land use. And that seems to be what people are really getting out of it. We do many spatial joins to give those tax lots attributes, which people could do if all we gave was the tax lot data. but it seems to be a really worthy endeavor to be, especially because it's repeatable, it's relatively consistent, to just do the spatial joins for people so they can just look and see what school district is my house in. Condos, I promise that could be an entire presentation, and I'm not gonna get into it, but condos make it very difficult to make these sweeping general statements about a primary building on a location, because this is tax-based. So condos have individual owners, and that makes things very difficult, and we have written code that teases that out as best we can to still make a statement about a tax lot, even though there are multiple owners of an entity on that tax lot. And deciding what to correct. This is one of my favorite things because we hear a lot about the quality of Pluto, not often in a good way. We are not the sources of this information, and there's only so much we can and should do to correct that information. So if we, for example, held up releasing Pluto because we would like the Department of Finance to correct the year built of a certain property, we would never release Pluto. So there is a certain amount of quality that we have to accept when we put it out. We can correct things that are especially our fault, like calculations of the number of units in a building if we're extrapolating from other information. So we can take responsibility for the data that we produce, but it's much harder for us to take responsibility for the source data that would take far too long to correct, if they would correct it at all, to put this out. So at the top level, we are very confident in the quality of the data product, but it's hard to say how accurate every single value is for every single building. And so how do we do it? I'm sure you'd love to know. You want the keyboard?
Yeah.
Yeah.
So.
Yeah.
Yeah. So knowing what Pluto is, how do we actually make it? And so to start from a very reductive point of view, we data engineering really are data in and data out, where we take data from a variety of sources, from Department of Finance, internal data sets. We also pull a lot of data sets from open data or other, web APIs, public APIs. We do things. And then on the other end of that, we're producing our data products, and we're working with teams to distribute them internally to, analysts within the agency. We publish to Bytes of the Big Apple, and we publish back to open data. So to, start unpacking this black box a little bit, the first step of that process is the archival of source data. Essentially starting from a point of, we ingest, we produce a variety of data products, more than Pluto. And so we archive, I think, around 180 distinct data sets that go into our pipelines. And so to really run pipelines effectively, we need to have a centralized data store where we can, access these data sets consistently, easily, and really have this sort of historical element to it, because most of the data sets we produce are these snapshots in time. And we want, really to be capturing that from source data to completion of the product that we're building. And so what we use for that is cloud object storage. I think most people here presumably heard of S3. We use effectively the equivalent, but offered by DigitalOcean instead of Amazon. It's called Spaces. It still uses an S3 API. And it just really makes sense for us as a sort of primary long-term data store over, say, something like local file storage or a database, for a couple reasons. One is just the flexibility. It's incredibly useful to be able to just archive raw data, just whatever format we're getting it, dump it in our data lake, to use sort of the modern parlance. Also, then we can, we have processes to take this data, potentially spatially reproject it if need be, output it in a variety of formats that are very easy for us to take into our pipelines, dump metadata about how we archived it, and really just have this, very free-form and flexible way of storing the data that's coming into our pipelines. The other very useful part of just sort of large cloud file storage, it's very cheap and scalable. So unlike, say, like if we were doing this all in Postgres storage is very expensive relative to things like modern warehouse solutions or cloud file storage. So this, Spaces really works really well for us, just for a variety of reasons. So once we have, sort of this, landscape of source data archived, ready to go, stored in a consistent manner, it's time to sort of, then get into more the meat of producing our data sets. We can sort of think of as our build cycle. And the first part of that is transforming our data. I think everybody understands generally what I mean when I say transforming data. Things like whether it's just cleaning source data or doing things like applying geocoding, the spatial joins that we're talking about, aggregating, categorizing, adding value to the data and actually producing our data sets. And our real workhorse for this is Postgres, and more specifically PostGIS, which is the spatial extension for Postgres. It's for a couple reasons. For one, it just sort of, for a while, has been one of the more mature and I would say accessible tools for transforming spatial data. I think a lot of data analysts and engineers are very familiar with SQL, how to write it and how to use it. And at this point, I think about maybe 90% of our transformation logic is written in Postgres. And what that looks like practically then is we have this data store that we're archiving data in, sort of rigorously. And then when we're actually building data sets, it's sort of at build time that we, import those data sets, load them into our production database, this Postgres database. Also actually hosted on DigitalOcean. I use the logo there for the data store because Spaces doesn't have a logo and I needed to put something there. This database is also living in DigitalOcean. We're doing most of this in the cloud. And so this database is where, we're actually running these SQL files, we're running these transformations. Once a data set's built, is when we then begin our QA process. And this has been alluded to a little bit. And QA, in how we think about it, is that there are really sort of two big types of quality checks that we're doing. One of them are these very domain-specific checks, where we work with complex data that requires a lot of domain knowledge to know what is expected, what are sort of certain deviations. And then, so those are the sort of checks that we work with data analysts, domain experts in capital planning, in our population division, in our housing division. And then sort of outside of that, then you can also have more data set agnostic checks. So one, just things like simple descriptive statistics. What's the distribution of a continuous variable column in your data set? But then more than just describing a single data set, starting to look at trends over time. So comparing the current build of Pluto to our last release and seeing how many tax lots have changed zoning district. That is a useful metric, but when you don't have a context for, well, what's a normal amount of change from one build of Pluto to the next, that also then blurs lines a little bit between domain-specific and data set agnostic tests, because then you get into, okay, well, is there maybe a calendar for when these big zoning changes happen? What would we associate these big changes in values in our data set with? So there's some amount of gray area between these two, but really, a big focus of ours now is trying to automate more of this latter category. And start having more automated just sort of descriptors of our data, and start moving from that to more automated actual checks of our data, and not just displaying information to look at, but having automated flagging. The main tool that we use for this is Streamlit. So again, on DigitalOcean, we have a dedicated server where we're running a Streamlit app. Streamlit is a Python package largely meant for dashboards. It's a very it's a very lightweight framework for making web apps to visualize data. And so this is where we, try to address both of these types of QA. To some extent, analysts are still going to sometimes be grabbing shapefiles from us, opening them in ArcGIS, or we're going to be querying our databases. But as much as we can, trying to codify their analysts' domain-specific knowledge, trying to continue to build utilities around exploring our data and determining outliers in our data, and getting those then into some sort of interface where we can, actually interact with it without having to code anything. And so once a data set passes QA, then it's actually time to distribute it. Essentially, that entails one, dumping back to long-term storage, where we're storing that in Spaces and DigitalOcean. And then, two, just knowing that the users of our data, we have a diverse set of users of our data that have many preferred tools. Some would prefer to do their analysis in Excel. Others are using ArcGIS and other, GIS tools. Some people are writing SQL and Python. So we're exporting, in a variety of spatial formats, as well as CSVs. And then those get distributed. Let's see. So that is largely sort of our big picture infrastructure. As you can see, it's pretty lightweight. That in general works to our advantages. For one, we are iterating quickly, and so it's very handy to be able to, tear down and replace infrastructure as we see fit as we're building it out, and not be too tied to, say, like a single cloud provider, and sort of be pigeonholed in any specific way. It also helps that, we can keep, as much as possible for now, our pipeline very open source and transparent and potentially reproducible if, somebody really wanted to, make sure that our pipelines are actually working correctly. So with this sort of being like the big picture, the next bit, right, is, well, how are we actually running this code? What's actually moving data around? What's actually triggering these builds? So our orchestration and control flow has a couple parts. It's also, I'd say, relatively lightweight. We have a lot of Bash scripts that are orchestrating things. More and more, we're trying to move from Bash to Python. We're always going to be using Bash for something because it is, sort of a workhorse scripting language just for running commands. But when possible, anything with complexity, dealing with entities, any sort of complex iterative logic, it's a lot nicer to be working in Python, where we actually, have a little more fine-grained control and, I would say, introspection into what's happening. We use Docker heavily to ensure that we're building data sets in a consistent environment and in a reproducible environment, whether on the cloud, on our own computers, wherever. And our outside of our Streamlit computing instance, we actually don't use any dedicated computing resources. Well, outside of also, I would say, our Postgres database. Postgres databases have computing resources built into them. But in terms of the code running our builds, we're running everything on GitHub Actions. At some point, we'll likely look into something. We've done a little bit of research. At some point, we're going to be implementing something along the lines of Airflow or Prefect, or some other orchestration tool to help organize our jobs that are running. But we love GitHub Actions. It's been incredibly useful. It's incredibly flexible. And if you haven't been using it extensively and need to automate a lot of cloud processes, highly recommend. It's tough to talk too much about sort of the Python code we've been working on without really getting into a lot of the code. But that is sort of, I would say, where one of our biggest focuses has been this past year in the work we've been doing. And that's sort of for a couple reasons. One is sort of, I would say, the more... Hello? Okay. One reason I would say...
That's the new cowbell?
Yeah, there we go. All right. Is just... Sorry. What am I saying? Yeah. So one of them is just, essentially just trying to abstract more code. Having broader code bases where for different pipelines we're rewriting a lot of the same code to do very similar things is just harder to maintain. It's harder to read. And it's just sort of, in general, the more you can abstract out code, write modular code, the better. I'd say the sort of more interesting way to think about that in terms of what we're trying to do is really distill down, from the perspective of our code bases, what is a data set? What is Pluto? Because obviously Pluto has a very specific meaning when we're talking about the data. It also does when we're talking about code. A year ago, Pluto was its own repository. So, Pluto was a README, a set of instructions. It was a collection of Bash scripts, collection of Python scripts, collection of SQL scripts, and was sort of overall, a a whole pipeline. But really starting to think about like, well, what actually separates it from our other data products that we produce? What really is it at its core is sort of two things. One, transformation logic. In this case, a collection of SQL files that, we can try to abstract out some of it, but to some extent, we're never going to abstract that out, right? We always have to do these transformations that are incredibly specific to Pluto. That sort of is a core element of what Pluto is. And then beyond that, trying to sort of reduce it down to something very declarative. So this is a YAML file on the left that is sort of our config for how we start a Pluto build. So where it has things like the name, things about the source data sets, how we're grabbing those source data sets. And so we're trying more and more to move to a world where we, essentially we have transformation logic, we have configuration, and then to actually create our data products, then we're really working on these abstracted utilities that take that configuration file, set up a database where build can happen, orchestrate that build, and then, produce the exports we need and distribute them. And that's sort of like where a lot of the focus in our automation is going. So that's where we are now. I think Damon now is going to talk a little bit about where we're hoping to go in the next year.
I'm definitely going to make sure we have time for questions so that people can get to lunch also. So you've heard about what we're doing, heard about our principles, all of this. I want to focus especially on the scalability part for what we're doing in the future and already starting to do. So standardizing our data sets, like Finn mentioned, we used to have code spread out in different places. Now we have a glorious mono repo, a word I love to say, where all of our code is in the same repository. We can use code for all of our data products. Distributing data is something we're starting to take more responsibility for because everybody's happier that way. If we can automate pushing data to open data, then we don't have to send emails to OTI with zip files, and they don't like that. We don't like that. So making that more automated and standardized is also very, very helpful. Orchestration and logging, like we mentioned, but I'll talk a little bit about logging. Data modeling and testing. That is very important to us and getting easier by the day. So this is just a picture of sort of our primary data sets, and that screenshot on the left is from the wiki of our GitHub repo, which is publicly accessible. That's how I shared the link to these slides, so I could open them here. And on the right is just the same representation, but those are folders in our code base. So the closer the code is to each other, the easier it is to standardize. Now, distributing data. I got 148 results on open data when I sorted by Department of City Planning. Are all of them active data sets? No, but a lot of them are. And as an agency, we're responsible for updating them. And on the right is just sort of a representation of how we're starting to think about data sets, that they start out as tables for us, they become files, and then they end up in destinations. And there isn't too much to complicate that last part. We send data to certain destinations. And so we're trying to use metadata to make these things more standardized and automatable. Automatable, that's a word. Orchestration and logging. Can't thank GitHub enough for letting us run code for free. So those GitHub actions that we run are free because we don't need too much going on. We don't need it to persist for too long. And so if we say build a data set and it takes an hour and a half or 3 hours, it happens. And so that does make logging difficult because now this is just maybe text that's printed out. Thankfully, we have a database that we're using, so we're starting to invest more in logging that we can persist and query so that we're populating a table saying, on Tuesday, we built Pluto. It took this long. It used these source data sets. And that can start to look like what's on the right, just a record of a build that we ran. It's not just text, it's structured information that we can save and query and learn from. And on the left, I happened to take a screenshot when we ran our most prominent GitHub action 800 times. And we probably built that 6 months ago, maybe 8 months ago, and we've used it that much. Not always successfully, that includes the failed runs. So modeling and testing data, and when I say modeling data, I really just mean describing data before you build it and planning that way. And so DBT, which stands for Data Modeling Tool, is my favorite thing to talk about, and we don't have time to really get into it, but it's basically a way to run SQL code in a more code-friendly way. Also, it forces you to model your data so that you end up with simpler queries like the one on the top right, and it lets you learn about the flow of data from one table to another so that you can visualize it very easily in the bottom right. And it also makes it very easy to test our data. So YAML files, you might hear about those a lot in the near future, but we can just say, we have these columns, we want to test them, and we don't have to write code to do that. We can just say, make sure that column's unique, make sure these columns have no null values and things like that. So you already know this, but it's your data, and we want to make sure you have access to it and can use it in the ways that people love to use it. And thank you. I'm going to keep the cats on the screen. I'm also not going to hold anyone for lunch if they got to go. But are there any questions for us? We got one in the back.
Yeah. As always, my favorite presentation is school of data. Data engineering. You talked a little bit, I think, and you mentioned about like allowing folks to be able to like build these jobs on their own. I think like developing the database last year, you talked a little bit about like how some of the data sets on DigitalOcean, the archive ones, they're not publicly accessible for like good reasons, but some of them could be publicly accessible from the archive, and then be able to run the builds yourself. How are you all thinking about that? I guess maybe since last year and then in the year going forward.
Yeah, I mean, since last year is sort of an interesting question because I'd say a year ago was a bit of an inflection point with roughly our whole team starting. So quite honestly, I have to say that in the last year, our efforts have very much been more focused on internal infrastructure than trying to make everything accessible. We have been sort of, with the Python utilities we're building, trying to, I think one of the longer term goals is making like a package that we could publish that people maybe could have their own plugins for. But a package that we publish where people can, if not making our data sets specifically, at least use similar utilities for having a system of archiving data, having a system for having data go through some sort of review and different stages. As far as the private data, I don't think we have a great answer for that right now.
Yeah, and even for the archived public data, we know that OTI is trying to standardize how all agencies share data internally and externally. So whether they go with a solution that uses a product called Snowflake or whatever they go with, we're going to be, I think, in sync with that. And if we happen to have the biggest collection of archived parks, Department of Parks data, then we contribute what we have to that. But I think our priority has been to make sure that people within DCP have access to these archives. And so I think it's also coordinating with agencies to not jump ahead and say, hey, we're going to publish all versions of your public data that you have put out ourselves, but it is a priority, definitely.
How is this connected to the building data? Because BBL code, sometimes I think it gets confusing with buildings, especially that buildings can appear and disappear, and the code is just entirely gone. And sometimes I have a table that I have a BBL code, and then I go after and I cannot find it. It's gone.
Yeah. So the snapshot part of that is important because if you're dealing with two tables that weren't generated at around the same time, then a BBL really might not appear. And there's also a layer of detail about billing BBLs. So you might have a single lot that has, especially condos, where every condo might have a distinct BBL. But if you're looking at 8 condos on one lot, well, in Pluto, we have chosen not to describe that lot with those 8 BBLs. And so you might have that issue where you're dealing with Pluto that it only has the BBL for one entity, but there are others that have BBLs that can't be joined to that table. So that is a limitation of Pluto where we're saying this lot has one primary billing BBL and we cannot represent all BBLs that are associated in reality with that lot. So
it sounds like you're also talking about just the historical aspect too, right? Of that BBLs disappear sometimes.
Yeah.
They get split and one of them doesn't inherit the BBL. And you just have 2 new BBLs, and if you don't know that, you are sort of out of luck. So I mean, right now I'd say, the tools are being able to go and find sort of an up-to-date BBL based on address. I know that, sort of in the works at City Planning, not by our group, but the group that creates Zola and maintains Zola is working on actually serving historical data. And I would hope that, that includes a tool to actually look up historical BBLs. Unfortunately, it's a slightly complex question, and it's a complex process sometimes to figure it out.
Question. So you said you do data quality checks. So do you do it for like say Trump Towers? It's 30,000 square feet, and then next year it's 10,000 square feet. Do you detect like
So
things
since
like that?
yeah.
People changing square footage of their.
Sure, and that's related to what I was saying about the source data and what we can take responsibility for. So we do try and flag abnormal changes. I'm not sure that we've really focused on this specific lot, this value changed from this to that. But it is more like, all of a sudden we have 10,000 lots that say that they have 100,000 units in them. That seems odd. And so we are more concerned with problems that we created than potential problems in source data that change from year to year. So if somebody files their taxes a little differently from one year to the next, we might detect it, but we're not going to prioritize fixing it if it's not something that we're really responsible for creating in the first place. So there are some things like, this says it has 0 square footage in the building. That's odd. We should inquire and let Department of Finance know that this is pretty frequent and a problem, but we aren't taking on the responsibility of investigating suspicious changes in tax filings, But it is detectable across versions of Pluto. So I just want to, yeah.
So my question is also follow up by the QA section though. Like once you detect that issue, how you actually alerting you guys or you're actually alerting to the owner of the data source to tell them that there's an issue?
So I think we have a long history, if Amanda wants to speak to it, of communicating systematic issues to Department of Finance. But is there anything you wanted to take on that?
No, it's currently an email to say,
Yeah.
here are the problematic records that we've identified in this latest version of Pluto to our current contacts at the corresponding agency.
Yeah, if there are structural issues like, these columns disappeared, or the format of these columns changed so much that we can't use it, that's a similar type of communication, but also a more urgent one, because we can't use the data that we're expecting from you. So there's always a big difference between like structural aspects of data and the actual values in the rows. But yeah, it's currently an email to our agency contacts to say that these things look strange.
Is those email are auto-generated, or is you guys just creating that component?
Yeah, so when we're looking at a data set like we were in a Streamlit web app, especially domain experts saying like, this isn't a normal amount of change. And we've determined that it's not because of our code, that then becomes an email to our contact where we're saying, manually, like this looks strange. But you were next. Yeah.
I wanted to ask about the planning process that you go through when you're thinking about creating the tables.
Mhm.
And I imagine the source data is not the same as what you end up as Pluto.
Nope.
So how do you think about the transformations that you're going to do, and how much actual planning do you do before you write the code?
Yeah.
And I also wanted to ask, because you said it's a snapshot in time, have you thought about like adding some like variable to, I mean, it's gonna get really large, but like just to document like release. So compile all the releases into one by having like some identifier or something like that. And then I wanted to ask a very granular question about geo support.
Gotcha.
I don't think I've ever heard of this package. Can you talk a little bit about what
Yeah,
it's for?
I'll do the first two first.
Okay.
So a lot of people like that ATM project in Data Through Design are interested in looking at all versions of Pluto. And I think that it would be valuable for us to join all of these tables. The columns probably haven't changed that much, so it might not be that hard. But since our priority is the frequency of releasing new data, I think we've prioritized making all versions available to people so that they can join them into one giant table when they need to. But a lot of people do it, and there's a lot of interest in it. And so we do prioritize stability of these columns so that that is always possible and not changing how we categorize things. And to your first question, which was about planning. So Pluto is unique because it's relatively old. It's so used, and the code is relatively complex. We don't plan anything because the expectation is that we keep putting out the same thing, and if it ain't broke, don't fix it. So with Pluto, we as a team have not done much planning of the source data and intermediate tables because we want to make sure that it's running smoothly and going, and we have not done much planning to revamp it. Now with a new data product, like something that we may have put together in the past couple months where we can start from scratch and people just tell us what they want at the end, we can do a lot more planning. And so that's where we're trying to kind of minimize complexity, especially. And we know our source data, we know our outputs, and we as a group will come together and say, okay, what do we need to know to get to the end? To join, usually we're just joining sources to get to the end product, but did you want to speak to
Yeah, I was going to say generally, and we've had a sort of new data product that we're working on these last couple of months, and it really was just a very iterative process with the domain experts of sitting down and talking about exactly like what specific language means, and so that we can know how we're going to translate that into SQL. What entities they're concerned with, all of those things, and then presenting them with data, working with actually another group working on visualizations of the data, and sort of all coming together and iterating together until we're all sort of in agreement about like what are the specific requirements of the data that we're producing.
And what really helps is having, I want to call it, example outputs. So for a given tax lot, if we know all of this source data, what do you expect to see in the output? And so now we have a goal that we can test in a very binary way. If our logic results in a different output, our logic is wrong. So it really helps to talk to domain experts and say, like, given these sources, what output do you expect to see? And now we have a goal to meet, and it's less ambiguous.
I think it's the longest part to make sure we understand the requirements, like what people actually want to see and what questions they try to answer with the data. And I think we spent the most time just getting down to what data should be included and also agreeing what would be considered a source of truth for each data set, because somewhat of like similar data could come from different sources, and some entities have data more often than others. So we also want to make sure we have that source of truth for each data set that comes in.
To the GeoSupport question, GeoSupport is written in C++. It's a binary package maintained by city planning that's existed for a while. That is essentially a package for going from an address text to spatial information. There are many publicly available geocoding packages. I think OpenStreetMap provides one, where you have some sort of Python API where you give a text and it will give you back its interpretation of that as spatial data. New York City is very quirky. We have buildings that have multiple addresses. We have streets that for one segment have a different street name or have a special overlaid street name. We have buildings with entrances on not the street that their primary address is on. And so GeoSupport takes those things into account. They take a lot of the data that our geographic research team produces and then uses that to turn addresses into spatial information. You can definitely Google it. I know there's also GOAT, which is the online tool for using it. It's like a web page where you can go and choose whether you want to look up, say, like a lat long point, or if you want a street segment ID, or if you want to provide an intersection of streets instead of an address, and then you can get geospatial information returned. So yeah, there's I think an actual desktop application. There's the web portal, and then there's Python bindings. And all of those are publicly available.
Yeah, I believe if you Google it, you will see at least one Medium article written by DCP, where we talk about all GeoSupport products we built and different products that use GeoSupport under. So just if, let's say you don't want to code, you just want to put address and get information back, there are tools like this.
So we might have time for one more question. No, you had your hand up.
Sure. I was wondering what struggles you have publishing an open source repo. Fear.
embarrassment sometimes. Everyone can see things that we're writing to each other, but it's mostly just
Your
making.
team decided, or was it a mandate from somewhere else, or how did
I think it was just a decision that all of our repos have been public. Thankfully, most of our source data is public, so that's really the hardest problem, is making sure that the data, not that the data is in the repo, but making sure that things that we're saying about the data or particular things we might be writing, because the data is not in the repo. It's mostly just making sure we're not oversharing. And the vast majority of what we're doing involves public data, but sometimes there's school-related data that might have identifiable information about students or projects that people are working on that aren't public. So I think that's just the hardest part, is making sure we're not overdoing it. But by default, it's what we're doing.
Yeah, just really with the ethos that, we're creating public data, and ideally, we can be transparent about how that data is actually being produced. Amanda Doyle, the founder of DCP Data Engineering, is in the room. And I think that was just sort of a big priority from the get-go of just, when possible, be transparent. And even if we can't be transparent about some of the data, the source data going into these builds, at least being transparent about the process and how those data are being used.
Cool. Call it.
We are out of time. Thank you so much.